Welcome our viewers. Today I want to look at the longitudes and latitudes. This is a topic in the Form 4 syllabus and I hope you will enjoy. Yes, I am your teacher of the day, Lusike Victor. Under the longitudes and latitudes, we are going to look at the circles, and we need to understand the great and the small circles. And one of the areas that you ought to understand is that all longitudes are great circles. Then we have got all latitudes are small circle except the equator. So what do we mean by a great circle? It means that it is a circle that divides a globe into two equal parts. So when we say the small circles, it means that it does not divide the globe into two equal parts. Into two equal parts. Now, we need to know what is a longitude and what is a latitude. So, the lines that runs from the North Pole to the South Pole, for example, if this is our globe, not for example, it is our globe, any circle that runs from the North Pole to the South Pole is a longitude. It is a longitude. So you can see this divides the globe into two equal parts. Also, this one divides the globe into two equal parts. Then there is one interesting latitude, that is the equator, that divides the globe into two equal parts. So they are the great and the small circle. So you need to understand that the small circles are latitudes except the equator, but the great circle, you can say that they are all the longitudes are great circles. So from that, I think it gives us a leeway to look at the distances along both the great and the small circle. Distances along the great and the small circle. So if we are calculating the distance along the great circle, distance along the great circle, the first thing we need to get the angle difference. The first thing we need to get the angle difference because it is given by the formula theta over 360 times 2 times pi then times r. And this one allow me to use the capital R, and it gives us the distance in kilometer. Well, you can also have beta times 60 to give us the distance in nautical miles. So, for us to come and calculate the distance along the great circle, it means it is our task to identify or calculate the angle difference. It is our part or our obligation to calculate the theta. So let us assume we have our globe there. This is our equator P. So these are the longitudes. Remember we said that they are the longitudes. So these are the longitudes, while the ones that will be running this way They are the latitudes. So let us assume at this point it is 50 degrees east. And at this point is 20 degrees north. And this is point A. Then there is a point B, which is also, it is 50 degrees east, and it is around, let's say, 30 degrees south. So if we will be moving along this longitude, remember we said that it is the distance along the greater circle. It is the longitude, it is the distance along the greater what? Greater circle. So we need to get the angle difference first, because we are moving from north to south. It means that we are going to do what? One point is on the south of the equator, and the other point is on the north of the equator. So it means that I'm going to add the angles. Am I clear? So it's going to be what? It's going to be 20 degrees plus 30 degrees to get 50 degrees. So this is our theta. That becomes our theta. So if you want to get the angle difference from this point and this point, it means that it's going to be, we are going to add because they are on different or opposite sides. Good. Let us also assume that we had to look at a point, maybe we needed to move from, to get the angle difference of these 2 points, that is point D and point F. And at this point is 15 degrees west, while this one is 50 degrees east. What we would have done, we would have taken 15 degrees west. So that is 15 degrees plus 50 to get what? 65 degrees. So that is the angle difference. In that case, that is the angle difference in that case. So why is it the angle difference in that case? It is because, number one, it is along the greater circle. It is along the greater circle. So it means for us to know how to calculate the distance along the greater circle, we have to calculate the angle difference within or rather we have to calculate the position of the places around that globe. So let me assume that I want to get now the distance from A to B. If I'm going to calculate using the formula in kilometers, it is going to be 50 over 360 times 2 times 22 over 7 times R. R is taken to be 6370 kilometers. But remember, they can give whichever value, you use what is going to be given in your exam. So let's use that one for now. It is 6370 kilometers. Yes. Can somebody give us the answer? It's going to be 50 over that one. So in kilometers, what is the answer? 50? 55, 60. 55? 61 kilometers. So let us assume we were getting the distance from B to F. Let us assume we were getting the distance from B to F. It means that this was our angle difference. So in kilometer, it's going to be 65 over 360 times 22 over 7 times, in fact it is 2 times 22 over 7, then times the radius, which is 6370 kilometers. So let's get the distance there. Yes, 7,229.4 kilometers, right? So it is approximated as 7229 kilometers. Then, so that is how we can calculate the distance along the Great Circle. That is how we can calculate the distance along the Great Circle. So we can also give the distance in nautical miles. We can also give the distance in nautical miles. So the formula of getting the distance in nautical miles is given as the theta times 60. Which always gives us the distance in nautical what? Miles. So therefore we have 50 times 60 to get what? That is 3,000 nautical miles. So if we want to get the distance from B to F in nautical miles, it's going to be 65 times 60. Get what?
39,000.
39,000 nautical miles. Nautical miles. So from there, we can now look at the distance along the small circle. Distance along the small circle. Remember, at the beginning of our lesson, we said that the Great Circle, it is a circle that divides the globe into two equal parts. And we said that the longitudes are all great circles. Then all latitudes are small circles in exception of what? In exception of the equator. In exception of the equator. Therefore, it means that if I'm moving along, this is the latitude. It is always given in degrees north and degrees what? South. So if I was to get the angle difference between maybe, let's say, A and P, point A and P, and at this point we can have it is maybe 7 degrees west, for example. So it therefore means I want to get the angle difference from this point up to this point. And because here I have 7 degrees west and here I have 50 degrees east, it therefore means if this longitude is in the east and the other one is on the west, it means that we do what? We add, because they are on the opposite sides. But if they could be in the same side, let's assume it is 50 degrees east and there is another one, maybe we say 40 degrees east also. It means that we take the larger minus the smaller angle to get the angle what? Angle difference. So let us get the angle difference between A and P. We are going to have it as what? The angle difference. Remember, we are looking at the distance along the small circle. So it means that if you want to get theta, it's going to be 50 plus 50 degrees plus 7 degrees. degrees. So it is therefore 57 degrees. That is the angle difference. Now, the formula that you're going to use here is absolutely different, but a bit of a difference with the previous formula. In that, if we want to calculate the distance in kilometer along the small circle, is going to be theta over 360 times 2 times pi, which is 22 over 7, then times 6370 cos alpha. Now this alpha, it is the latitude, and remember the latitude is given in degrees north and south, but the longitudes are given in east and west. So therefore cos latitude. So any cos here, it is the cos what? Latitude. Therefore, if I was calculating the distance along this, it's going to be 57 over 360 times 2 times 22 over 7 times 6370 cos. The latitude there is 20 degrees. So what is our answer? What is our answer? That is 57 over 360 times 2 times 22 over 7 times 6370 cos 20. What is the answer? Yes, 59?
57.
50? 57?
57.9.
57.9.
59.57.
So it is 59.57.3 kilometers, which is approximated as what? 57 kilometers. And also, if we wanted to get the distance, along the small circle in nautical miles, this is the formula that could be applicable. It is theta times 60 cos alpha. And remember, our alpha is cos latitude. Therefore, it means that it is going to be 57 times 60 cos 20. What is the answer in nautical miles?
32, 13.
52?
32.
32?
13.
32, 13 nautical miles. Yeah. So it is important for you to know how to calculate the angle difference. Also important for you to know how to get the distance in kilometers and in nautical miles. Yes. So to wrap up our lesson today, it is important for us to go through what we've learned from the first step to where we are, and allow me to point out some few key important things. So up to where we are, we've realized that we've got great and small circles. And we've said that greater circles are circles that divide the globe into two equal parts. Then we've said that small circles, these are circles that do not divide the globe into two equal parts. And we've said there is an exception of the equator. An exception of the equator. Now, from there, it was also nice for us to know the positions or how to get to the positions. And this is what I can stress. I can stress that if, for example, they are giving you to get the position, maybe we can have our globe there. This one is our globe. Then this is 35 degrees east. And here it is 15 degrees west. So it therefore means if I want to get the angles between point A and B, it is going to be the angle difference of this longitude. And the longitudes are given in degrees west and degrees east. So, because number one, this one is past the Greenwich meridian, it means that I'm going to add. They are not on the same side. So if I want to get the angle theta, it is going to be 35 plus 15, which is the same as, that is 5, 10, 20, that is 50 degrees. But if we assume that we had another angle here, which is maybe 17 degrees east, for us to get the angle difference is going to be that 5 minus 17 degrees. That will give us the difference. Why? Because they are all in the same side, on the same side. They are all on the same side. Same applies to the latitudes. If the latitudes we want to get the difference for are on the same side, it means that we are doing what? We are going to minus the greater, the smaller from the greater. If they are on the opposite, let's say that is 35 degrees north and maybe 15 degrees south, it means that we are going to add to get that difference. I think that is one of the things that are important for you to note. The next thing that is of essence is for us to get the formulas to calculate the distances in kilometers and in nautical miles along the greater circle and the small circles. Along the greater circles in kilometers, we calculate it as theta, which is the angle difference over 360 times 2 times pi, then times r. Gives us the kilometers, the distance in kilometers. Then we have theta times 60. It gives us in nautical miles. So here it is in kilometers and here it is in nautical miles. So these are distances along the greater circles. Then, using the same way or the same format, we can calculate the distances along the smaller circle. Along the smaller circle, e.g., P and maybe Q. It is along the smaller circle because it is along this latitude. Maybe we can call it X degrees north. So we can calculate that using this formula. That is theta over 360 times 2 times pi times r cos alpha. And remember our alpha here, it is the cos latitude. It is the cos latitude. So it means our alpha is the latitude angle. Then, if I want to get into calculate that one into nautical miles, it is supposed to be theta times 60 cos alpha. So here it is in kilometers and here is in nautical miles, while this is distances along the smaller circles. And thank you for attending our lesson today. Stay tuned for more. Thank you.